Yeah, good morning to all of you. In the previous lecture, we have discussed about the force between two point charges, which is Coulomb's law. In this lecture, we have discussed about the force between multiple charges. If we have a Q1, Q2, Q3, Q4, dot dot dot, means if we have n number of charges, then what is the force expression and what is superposition principle and importance of superposition principle. So what is superposition principle? This principle, so first we will discuss about the superposition principle. Superposition principle. So this superposition principle states that the force between multiple charges is the vector sum of all the forces exerted due to all these charges. So if we have, let's say, if we have a Q1 charge and this is Q2, this is Q3, this is Q4 and dot dot. So force due to these charges, force, so Q1, Q2, this is, and force due to this Q1 charge is, let's say, F1. So basically we have a multiple charges and the force between these multiple charges is the vector sum of all these charges. So what is the force profile? What is the force on Q1 due to Q3? Q1 due to Q3. So this is F13 and force between Q1 and Q4 is F14. Force between Q1 Q2 is F12 and the separation distance between this, let's say, R13 and Q1 Q2 is R12 and Q1 Q4 is R14. These are vector quantity. So the total force is F is vector sum of F12 plus F13 plus F14. So because of this principle of superposition, we can add all these forces. So what is F12? So F12 is 1 upon 4 pi epsilon 0 Q1 Q2 by R12 square R12 square. Similarly, what is force on this charge Q1 due to Q3? So this is F13, which is 1 upon 4 pi epsilon 0 Q1 Q3 by R13 square R13 unit. Similarly, force on this Q1 charge due to this Q4, which is F14. So 1 upon 4 pi epsilon 0 Q1 Q4 by R14 square R14. This is unit. Now adding all these F1, F2, F3 and F12, F13 and F14. So we have total force is 1 upon 4 pi Q1 upon epsilon 0 Q2 by R12 square plus Q3 by R13 square plus Q4 by R14 square. This is R12 vector, this is R13 unit vector and this is R14 unit vector plus dot 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 dot. If we have n number of charges, so we can extend our expression. If we have n number of charges, then this is Q1 by R1 and square R1 and unit vector. So now adding this, so we have Q1 by 4 pi epsilon 0 summation I equal to summation I equal to 2 to n qi upon ri r1 sorry r1i okay. So this is the total force due to n number of charges. So the objective of this lecture is to provide a mathematical expression for a force between multiple charges and principle of superposition. And principle of superposition is an experimental fact. So superposition principle is an experimental fact, not a logical necessity. So this is experimental fact. Without this principle says that when these charges, when force experienced on this q1 charge due to this q3 charge, so this q and force on this q1 charge due to this q2 charge and force on this q1 charge due to this q4 charge are entirely independent. They are not going to interact with during the summation. The force F13 not interacted with this force and this F12 not interacted with this force, and this is the beauty of this principle of superpositions. So in this way we can find out the force between multiple charges. So there are several examples to find out the force between multiple charges in which, so let us see that how to deal with the multiple charge system, means how to find out the force on a multiple charge system. For example, if we have let me write the example to understand the concept of multiple charges. If we have an equilateral triangle, so if we have an equilateral so we know what is the property of equilateral triangle. So let me just draw the geometry. So what is the example? So example which is based on force due to multiple charges. So consider the charge, we have equilateral triangle as indicated in figure. In this equilateral triangle, the Q charge is situated at the vertices of this triangle. So let's say this is A, let me put the name, this is A and this is B and this is C. So plus Q charge situated at one vertices of this equilateral triangle, and the property of this, what is the property of this equilateral triangle? That three sides are equal and the angle between them is, angle is three sides, all sides, property of equilateral triangle. First, all sides are equal. Second, angle is 60 degree. Angle between them is 60 degree. So this is the property of equilateral triangle. And what is our job or what is our objective in this problem? That what is the force on these charges, or what is the force on each charge? How much force experienced on the vertices of this equilateral triangle having plus Q plus Q plus Q. So because of this, and what is the nature of this force? We have already discussed in the previous lecture that how to recognize the nature of this force. So these two charges, so force on this, let's say this is Q1 is Q, Q2 is Q, and this one Q3 is minus Q. So force on this Q due on this Q1 charge due to this Q2 and this Q3 charge. So in this direction, what is the nature? Let's say this is F1. This force is F1, and force on this Q1 due to this Q2 is F12, and force on this Q1 due to this Q3 charge is F13. So we have different kinds of situations. So at least we can say that okay, the nature of force is this force on Q1 due to this Q2 is attractive. So what is the nature of force? We can find out the nature of force on each vertices of the equilateral triangle. We know the property of equilateral triangle. So the force on this Q1 due to this Q2 is F12. So F12. We can find out F12. We can find out F21. This is F2. Force on this Q2 charge is F2, and force on this Q2 due to this Q1 is F21. Force on this Q2 charge due to this Q3 is F23. So we can draw a parallelogram. In this case, we can also draw a parallelogram. And force on this Q3 is, this is F3, and this is force on this Q3 due to this Q2 is F23, and similarly. So these are the parallelogram. We can apply the law of parallelogram in order to find out the force on these individual vertices, but without solving, we can at least guess the nature of force. What is F12? What is the nature of this F12 force? So F12 is, because both the charges are Q and Q, positive charge. So nature of F12 is repulsive, and nature of this F13 is attractive, and nature of this F23 is again attractive. So there are a number of ways that examiner can ask variety of questions, that what is the nature of this. If the three charges are placed at the vertices of triangles, then what is the nature of force due to each charges, and what is the magnitude of forces at each charges, and what is the resultant of force, and what is the total force at each charge. So this is the best example to understand the concept of force due to multiple charges. We can also find out the force at the centroid of this triangle. We can also find out the force. In another example, we can say that find the force at the center of the equilateral triangle. Centroid of the equilateral. So in next video we will discuss about this particular example, that how to find out the force due to centroid of the equilateral triangle. So it's all about the force due to multiple charges. Thank you.